Hello, myself Dr. Ajay Sharma, Department of Electronics and Communication Engineering, James Engineering Management Technical Campus, Greater Noida. The subject that I teach in this semester is digital communication. This subject is for BTech 5th semester Electronics and Communication Engineering branch students. And the topic that I will discuss today is uniform and non-uniform quantization. The digitization of analog signals involve the round off of the values which are approximately equal to the analog values. The method of sampling chooses a few points on the analog signal, and these points are joined to round off the values to a near stabilized value. Such process is called quantization. Now, try to understand this particular concept. Quantization come in the picture when you have to take a samples. You have to take a samples from the analog signals, right? So quantization come in the picture when you convert analog signal into a digital signal. So in this particular process that we already discussed in previous lectures, we have to take a samples, some samples of analog signals, right? And we take samples according to the rule given in sampling theorem, right? So first stage is take the samples according to the sampling theorem from a modulating signal, which is of course a analog signal. Once you get the samples, each sample represent a certain voltage level, right? For example, if you take 10, or for example, if you take 5 samples, right? So each sample represent a voltage level. For example, first sample represent a voltage level of say 2.6 volt. Second may be a 3.8 volt. Third may be a 4.2 volt. Fifth may be a again 2.3 volt. So each samples have a certain voltage level, right? Now we have to approximate these sample voltages by some real number. For example, if you have a 2.4 volt, right? This 2.4 volt should be approximated at a certain real voltage level. For example, 2.4 volt should be converted as 2 volt. 2.6 volt converted as a 3 volt, because if you do a quantization process and if you take a voltage, step voltage is 1 volt, so 1 volt means the middle point is 0.5 volt, right? So something is above 0.5 come in the category of 1 volt, and something is below 0.5 come in the category of 0 volt, right? So once you have a samples that represent a certain voltage levels, these voltage levels should be approximated, should be quantized. So this whole process is called as a quantization. So quantization nothing but you have to approximate all voltage levels of the samples, the sample that you take from some modulating signal, right? Look at this figure. This is an analog signal that you see on the screen. So the analog to digital converters perform this type of function to create a series of digital values out of the given analog signals. The following figure represents analog signal. This signal to get converted into digital has to undergo sample and quantizing. The meaning is that the signal that you see on the screen is an analog signal, and to convert this analog signal into a digital signal, you should perform a process of sampling, then a process of quantizing, right? So after sampling, we have to do a quantization process, right? And after quantization, we convert this real values into a digital bits, because every real number is converted into 0 and 1, that we already know. Look at this particular picture, so the quantizing of a analog signal is done by discretizing the signal with a number of quantization levels. Quantization is representing the sampled value of the amplitude by a finite set of levels, which means converting a continuous amplitude samples into a discrete time signal. The following figure shows how an analog signal gets quantized. The blue line represents analog signal, while the brown one represents a quantized signal. So if you look at that particular picture, we have an analog signal, right? And we have to take the samples, and after we get the samples, we have to quantize these samples. So look at this particular picture. The first sample is at 0, 1, 0, 1, and this represent a value 6. Means the first sample that we have, for example, have a 6.1 volt, and this 6.1 volt approximated at a 6 volt, and 6 volt represent 0, 1, 1, 0. Second sample is at 0, 1, 1, 0. That represent a 7, right? And for example, this before quantization, it may be 7.3 volt. So 7.3 volt come in the category of 7 volt, right? So by taking the sample and quantized, so all these are the samples. So number one sample is 0, 1, 0, 0, 1, 1, 0, then 0, 1, 1, 1, then 1, 0, 0, 0, then 1, 0, 0, 1. Again, we have 1, 0, 0, 0, 1, 1, 1, right? So this blue line is a continuous time signal, and this brown line represent, discrete type of signals, right? So both sampling and quantization result in the loss of information. That is true, because you violate the analog signal, and analog signal is nothing but the information. If you do anything with the information, you have to you have no right to change the real information. So engineers can't even touch an analog signal, information signal. And what you have to do in the quantization process, you have to violate that, because you have to convert 6.1 by 6 volt, convert 7.3 as a 7 volt, 8.6 as a 9 volt. So this is the loss of information, right? So we compromise. So we have to compromise on that. We will discuss how this compromise costs us. The quality of a quantizer output depends upon the number of quantization levels used. Actually, the quality of the quantizer output depends upon the number of quantization levels. Means how many quantization levels that you have. Actually, it depends upon the step size. If you have a step size of say 1 volt, having certain number of quantization level, and if you increase the step size say 2 volt, the quantization level decreases. So if you increase the step size, then you have to decrease the quantization level. But when you decrease the quantization level, you have to degrade the quality of the signal, right? The discrete amplitude of the quantized output are called representation level of the construction level. The spacing between the two adjacent representation level is called a quantum or step size. So what is the step size? The step size is the voltage between the two levels, two consecutive levels, right? The following figure shows the resultant quantized signal, which is in the digital form for the given analog signals. This is called staircase waveform in accordance with this shape. So the shape after the quantization process, the shape that we have, look at this step is, of course, this shape is a sinusoidal shape, but it's not a continuous, it's a discrete. How this becomes discrete? Because we take the samples of a modulating or analog signal. So see, this particular signal is not a continuous time signal, it is a discrete time signal, right? And we take the samples. We take the samples from the analog signal. So, and the shape of this particular signal is a staircase waveform. This is a staircase waveform. The shape that represents this brown shade is just a staircase waveform. There are two types of quantization: uniform quantization and non-uniform quantization. The type of quantization in which the quantization level are uniformly spaced is termed as uniform quantization. Means if your step size are maintained uniformly, means if your step size is 1 volt, then this 1 volt should be maintained throughout the quantization process. Then that process comes in the category of uniform quantization, where you can't change quantization level. It is fixed. If you fix the quantization level, it uses if the step size is 1 volt, this step size should be maintained at 1 volt throughout this process of quantization. Then this process is called as uniform quantization. And a non-uniform quantization means your step size is flexible. So there are two types of quantization. These are mid-rise type and mid-trade type. So we will see in next. Look at these two type of quantization. First figure shows mid-rise type uniform quantization, and second figure represent mid type of quantization. So these are the two figure of type of quantization. Next figure we will define these two type of quantization. The mid-rise type is so called because the origin lies in the middle of a raising part of the staircase. Just look the graph of first. The quantization level in this type are even in numbers. The mid-trade type is so called because the origin lies in the middle of the trade of the staircase, like graph. The quantization level in this type are odd in number. Both the mid-rise and mid-trade type of uniform quantizers are symmetric about the region. So thank you very much.